Now the thing with this, when we talked about graphing, is it had to be in slope-intercept form to be graphable. This guy already is. So in this case, what's the slope? 1, because there's an understood 1 there. And the vertical intercept? 2. B is 2.
Oh, we can make it B because I keep going I and C.
You can do that too.
Okay.
That is the y-intercept. You just want to be sure you remember it's the y-intercept. Now this one, this is a little trickier because it's not in slope-intercept form. And factoring is good, but it doesn't always make it the easiest to graph. And for substitution, we're going to have to solve for y. So what do I have to do to get this y all by as lonesome? Get rid of the 4x first. Start on the outermost layer away from the variable. Remember, I think I used this analogy. Think of an algebra like an onion. Algebra problem is like an onion. It has layers. You peel the layers away from the outside in. Yeah, like Shrek. Ogres have layers. Onions have layers. Algebra problems have layers. Yeah. So 3y is equal to negative 4x minus 15. The other thing I see a lot of has to do with signs. Signed numbers are a big headache, so watch that in these. Now I can go ahead and divide by the 3. So y is going to be negative 4/3 times x, and then negative 5.
Well, can we do like the 4, 0, 3y thing?
Oh, the 4 is, yes. If you can find the intercepts and make them fit on the graph and get a good line, that will work. The nice thing about solving by graphing is really the important part is not so much in doing this. It's getting the graph paper out and making sure that you can plot whatever points you need to get it. The only problem with doing them all by intercepts is if it goes through the origin, you don't have a second point to graph off of. What's up? You could. But I don't like to write it with the negative 15 in the front, because what that does is it makes it harder to look at this equation and pull out the slope and the intercept. That's the important part. How would you graph the fraction? Well, the one nice thing is, since this fraction here is the slope, it's the rise over the run. So it's I go down 4 over 3. Right. So let's graph this guy. Slope of 1, intercept of 2. So here's 2. And there it is. Let's see, I have a straight edge here somewhere. I had a straight edge. If I can't find it in a few seconds, I'll use something else. I'll use something else. Shoot. Lost my sticky notes. All right, there we go. Yeah. Hey, guys. Guys. Thank you. Now, the second equation has an intercept of negative 5. So that's down here. 1, 2, 3, 4, 5. And a slope of negative 4, 3. That means I would go down 4 and over 3. Or I'll go back 4, 1, 2, 3, 4, and up 3. 1, 2, 1, 2, 3. And that works too. So this line has that slope. And then I can look, and this is where they seem to cross, which looks like 1, 2, 3, 4, negative 4, 1, 2. Here's the good news. You'll have another chance to show me that you got this. In fact, tonight's homework is section 6.1 stuff, solving by graphing. So you got some more time to show me that you got this. It's also why we spent Monday practicing graphing, because this is what you had to be able to do.
Did you already put in the homework grades from yesterday, the 2 papers? Yes.
Any more questions on this guy?
It sounds stupid, but how did you get to negative 4/3?
Oh, negative 4/3? Not stupid at all. Good question. Remember that I divided both sides by 3? You have to divide everything on that side by 3. So negative 4 over 3 is where that negative 4/3 comes from. And then negative 15 by 3 is a negative 5.
Yeah, I'll figure it out.
Yeah. All right. Sweet.